Should we give a little time for the folks to join?
Yes,
Uh,
yes, yes. We'll wait. No
yeah,
problem. We'll wait.
yeah,
Yeah,
because
we
it's
already
just
posted.
right. It's just 9, so we want to make sure that people don't miss in the beginning.
Yep.
We have a little time because we have about 45 to 50 minutes content, so I think we are good. We have to wait a little in the beginning.
Sure. Yeah, yeah. We'll do.
It's a Saturday morning in India, right? So a lot of time people don't wake up at time, right?
Exactly.
Hello, everyone. We are going to get started, just waiting for a little bit so that others can also join for a minute or two. So sit tight if you want to grab a water or tea or coffee. We're going to get started right away, though. Yeah, looks like the count is increasing, so it's better to let's start at 9:05. That way we might get some more members join and they don't miss anything in the beginning.
Yeah, yeah. Sure. We'll do. Yeah.
In one more minute, we'll get started. We are just deliberately waiting. So if somebody is running late, they can join and they don't miss out any portion of it in the beginning.
Which summit it is, Rakshit, you are going to in US
Oh, yeah, I
summit?
was in the Databricks Data and AI Summit in San Francisco,
Oh,
and yeah, I'm in the airport. I'm going to go back today. My flight got
mhm.
delayed, so
Oh, okay.
yeah, so I'll be taking a red eye going back to
Oh,
my place, which is Michigan. I'm actually based out of United States, so I'm in
got it.
US. Yeah.
Got it.
All right, I think we can get started now.
We can get started. Yeah, yeah. Charita, stage is yours. Just hand over the stage later to the Rakshit. Okay. Please introduce her. Thank you.
So, good morning, everyone, and welcome to Data and AI Horizon Virtual Series Volume 1, proudly presented by Data Analytic Group in collaboration with Microsoft Fabric community members and industry experts. Today, we have an exciting lineup of sessions covering Microsoft Fabric, generative AI, data platforms, analytics, and Power BI. Whether you are a student, data professional, engineer, or AI enthusiast, you are going to gain practical insights from experienced industry leaders. I am Charita and I'll be your moderator for today's event. Let's begin our learning journey with our first speaker. To kick off today's event, it is my pleasure to introduce our first speaker, Mao Rakshit. Mao is a seasoned data, AI, and analytics solution architect with extensive experience helping organizations transform data into actionable business intelligence. She has worked across modern data platforms, AI solutions, and enterprise analytics architectures, enabling organizations to make smarter and faster decisions. In this session, she'll explore how AI powered real time intelligence is reshaping modern enterprises and how organizations can leverage Microsoft Fabric and generative AI to drive data driven decision making. Please join me in welcoming Maur Akshit for her session titled AI powered real time intelligence, transforming data driven decisions with Microsoft Fabric and generative AI. Stage is yours, ma'am.
Sure. Welcome, everyone. This is me. As you can see, I'm in the airport, so I'm going to turn my camera off. Just wanted to let you all see that I'm like you can see my face. So now that the intro is out of the way, I'm going to talk about Microsoft Fabric real-time intelligence service, and we'll go through many different, I would say within that capability, all the different features and services, and we'll take a use case and we'll show you a real life use case as how you're going to apply these services. And there's a big part of this is a demo. It's not a lecture alone. I will first explain you the scenario and then we are going to see hands-on demo for about 20 minutes. So you're going to be able to see within the fabric how I'm building all those stuff. I'll explain all of those. Okay. So now with that, I'm just going to start sharing my screen and let me know if you're able to see. So I think we have about uh, how many of you are? Yeah, I think the counter is increasing. We have about, hey, if you don't mind, Rajendra Charita, take some screenshots for records who are joining so that,
Yeah, we are doing
yeah,
backend. Yeah, we are doing
awesome,
that
awesome.
actually. No problem.
Okay, thank you so much. All right, guys. So this is a really interesting topic, as I was mentioning, or Charita gave the intro. Real-time intelligence is extremely important in this time of our, the way the country, the whole world is moving, where everything is getting, you know, converted to automated operations through agentic AI. So we need fresh data. That's why we are talking about real-time intelligence. So let me get this. This is actually my session. I recorded it just in case if there is anything last minute technical issues shows up. So let me know if you are able to hear the sound correctly. I'm going to play this, huh? Okay, so
I'm not able to hear the voice. If you're there,
oh,
I'm not able to hear. Yeah.
okay. So hold on. Um, are you not able to hear the sound? Okay,
Yes.
sorry. Yeah, yeah. Let me just make sure that, yeah, the shared sound was not there. Thank you for letting me know.
No
I
problem.
wasn't sure. Okay, let's get started.
Yeah.
About something that is becoming increasingly critical across industries. That is how we move from simply collecting data to actually acting on it in real time. This is not just about dashboards or reports. It is about building systems that can respond, assist, and guide operational decisions as events are happening in low latency fashion. So before I begin, just a bit about the title. The title of the session is AI-powered real-time intelligence, which is to transform data-driven decisions with Microsoft Fabric and Genium. So in today's environment, organizations have more data than ever before. So the challenge really now is no longer the availability of the data. The challenge is the speed of decision making. How quickly can we detect a problem? How quickly can we understand it? And most importantly, how quickly can we act on it? So in this session, I'll walk you through how Microsoft Fabric real-time intelligence enables that flow, that life cycle. We will cover ingestion, real-time analytics, anomaly detection, contextual reasoning, and decision support. And then I'll show you a live demo where the entire pattern is executed end to end with a simple scenario. So a little bit about me. My name is Rakshit. I am a modern data platform lead and architect at Accenture and Avanade with over 26 plus years of experience in data engineering, analytics, and AI. My work focuses on building enterprise scale data platforms using technologies like Databricks, Azure Data Platform, and Microsoft Fabric. I specialize in real-time architectures, lakehouse platforms, and AI-driven data systems. I also am a Databricks champion, solution architect, and a frequent speaker and modern data platform and AI. I enjoy teaching and sharing knowledge, and this topic is something I'm particularly passionate about because it represents the next evolution of how data platforms are used in the real world operations. Okay, so this slide represents the core idea of the entire session. Everything we are discussing today revolves around the flow, this flow. So we begin with a signal, which is telemetry data coming from vehicles or fleets, such as brake temperature, battery temperature, or delay in minutes. Now we move to detection, where we analyze those signals to determine whether any incident is occurring. Then we add context. This includes business information, for example, route priority, depot information, and available replacement vehicles, etc. After that, we move to decision. The system evaluates the situation and recommends the next best action. And finally, we execute that action, typically under human approval or guidance or governance. So the key message here is simple. Dashboards do not fix incidents. Actions fix incidents. And real-time intelligence becomes powerful only when it closes this loop from signal to action. So we start with the sense layer. Sense layer is basically how do you capture and store the live signals. Telemetry data is getting generated continuously from these vehicles and devices. And this includes
One quick thing I wanted to mention, this use case is for a fleet management operation scenarios. Think of Amazon. Let's say it's not really Amazon, but a fictional Amazon. Okay, so Amazon is a global corporation. They have so many delivery trucks roaming around the entire world, right? And it's important for Amazon to be able to deliver those, goods to their customers on time. Think of Christmas, winter Christmas break, particularly in US, right? Before Christmas, normally they exchange presents. At that time, all those deliveries have to reach on time. So the time matters, like low latency. You really have to act if something is like if a truck is delayed due to certain malfunction of battery or any other conditions within the truck or traffic delay, you have to intervene and send, let's say, replacement vehicle or any repair or whatever it is that is necessary, so that there is no delay in terms of the SLA. that Amazon has to deliver, or this particular transport company has to deliver their goods to the customers. Okay, so I'm going to start this again.
Temperature readings, delay matrices, and other operational signals. Event stream is the service that will ingest this data in real time and routes it to the system, into the system, which is Fabric RTI. An event house stores that data and enables fast analytical querying using KQL language. The real-time dashboard provides a live view of these signals as they occur. So this layer ensures we always have a real-time understanding of what is happening across the system. So that's your sense layer. Next is detection layer. Okay, so detect layer is how do you turn this raw telemetry into real incident? So we combine multiple signals to identify meaningful incidents rather than relying on a single threshold. For example, high brake temperature, high battery temperature, and increasing delay together indicate a true incident or operation issue, not individually. So we compute an incident score and use activator to trigger alerts immediately. So that's your action. This is where the system becomes aware of issues in real time rather than just collecting the data and processing it or doing decision later. Next is context layer. What is context? Context is king in the age of AI. Context gives meaning to these telemetry time series events. So detection alone is not enough. We need this additional contextual information that will enrich these signals with business information such as route priority, which route is high priority, where are the depot locations and available, what are the possible replacement vehicles are around there. So this allows the system to understand the operational impact of an incident. So context transforms these alerts into actionable insights. So context helps you to decide what action needs to be taken. So next comes the original, obviously, decision layer. This is where you're going to decide and expose what is happening through agent, copilot, and GraphQL. So the data agent enables decision intelligence. It answers questions such as what is happening and what should be done in natural language. It explains the situation and recommends actions that needs to be done. This significantly reduces the time required to make decisions and improves the operational efficiency. If we go to the end-to-end flow action map for the demo, basically what we see is this slide shows the complete system flow. Event stream captures signals. Event house detects incidents. Activator triggers alerts. Context enriches the data. Data agent recommends actions. And finally, actions are executed through copilot or human. This is a closed loop system designed for real-time operations. So this is that architecture flow. As you can see, left-hand side, it has Apache Kafka, Confluent Kafka, Azure SQL DB, CDC data capture, Cosmos DB, CDC, MQTT, event grid, MQTT, Kinesis, Confluent Kafka, etc. These are generating so anything connected to device or the emitting telemetry, that's that event stream. You can ingest through event stream. That's that event stream of events that you can ingest through event stream service. Then you can process it and you can store it in event house. You can act on it through the activator. You can you visualize it through real-time dashboard. You can add contextual meaning to it with digital twin builder. You can query and reason on top of that data stored in event house using KQL query set and Copilot. You can create complex visualization with Power BI. You can also discover and catalog all of these streams streaming data in the real-time hub as a catalog repository, and you can also convert them to one-leg table as well. So that's your real-time intelligence within the Microsoft Fabric platform. Okay. So now, how do we scale this scenario to enterprise level? So at enterprise scale, the fleets generate millions of telemetry events per hour. So the scale would be huge, and these services has the capability to scale with that volume. Each vehicle continuously sends multiple signals, including their location, mechanical status, driver behavior, etc. So we are talking about 250,000 plus vehicles, 15 million plus telemetry per hour, GPS sending signal every 30 seconds, and there is a bursty traffic during peak hours, etc. This requires real-time processing and low latency, fast decision making. Fabric real-time intelligence enables this at scale by combining streaming ingestion with fast analytics and operational triggers with all the services we discussed. Okay, so now this is that reference diagram. You can see we are ingesting the telemetry from the fleet using Azure Event Grid MQTT through event stream into the event house. Also ingesting the other contextual information like depot information, vehicle specification, all the other information through ERP, from ERP system through data factory into the one lake as delta table. And then those event house and structured data, real-time data in event house and other structured data in one lake as delta table are used to do model training for prediction. And we'll see what kind of prediction scenario we can use here for optimization. Now, this event house data can also be visualized, including geospatial information through real-time dashboard, and it can also be connected through direct query mode with Power BI reports for other complex data visualization. And activator is always there to be able to alert notification or emails on any downstream processes based on any threshold being met by the conditions that you have defined in your event house for the telemetry that you're receiving. Okay, so this fleet RTI architecture, what are the operational phases? These are the 4 phases you can think of. One is ingest and process, like we saw in this picture. This phase is ingestion. This is transformation and enrichment. This is train, and then this is visualization and activation. So ingest is basically utilizing event stream. So ingest and process using event stream, analyze and enrich using event house, train predictive models such as optimization algorithm models, route optimization, continuous learning of the system to be able to improve the performance and optimization of the entire fleet operations, and then visualize and activate using dashboards and alerts. This provides a complete life cycle from raw data, telemetry to action. Now, telemetry enrichment for operational intelligence is raw telemetry alone is not sufficient. We combine it with metadata such as vehicle details, vehicle specification and maintenance history, driver profile, driver schedule, etc. We also integrate it with external telemetry that is coming from traffic in the in the roads and weather conditions, fuel prices, fluctuation, and road conditions, etc. This creates a unified data set that supports better operational decision making. So you're not only dealing with that telemetry coming from the fleets, but all these other associated details, environmental specific telemetry, other contextual enterprise information to be able to make better decision. And that data set gives you a unified operational view, supports maintenance, routing of vehicles, performance optimization, and delivery prioritization, etc. The prediction layer or prediction intelligence, predictive intelligence, that is basically, what are the different things that you can do with this prediction layer using machine learning models with that data is predict maintenance, forecast failure of these engines or fleets, schedule proactive repairs for those, so that it will not become a costly downtime. Then route optimization based on traffic and weather information, optimize the route of these fleets and minimize the time taken as well as fuel consumed. Then fuel efficiency also, identify inefficiencies in the fleets and then reduce cost and reduce emissions also. Driver analytics, it can also do the driver analytics of the behavior of the driver, how the driver is following the safety guidelines and complying with the rules or not for their coaching. Then you can also do demand forecasting with respect to how much more fleet would you need. Are you ready for any kind of additional I would say business expansion for operational readiness, etc. Those also could be forecasted for the demand. Next is visibility and activation layer. So visibility is through the dashboard. Dashboards provide you real-time visibility, real-time dashboards. Activators enables you immediate alerts and actions. Natural language interfaces through the data agent and copilot makes the system easier to use and makes people more productive and democratizes the access to information and insight from the data. And that becomes actionable as well. Now, the implementation roadmap. The system could be implemented in 3 phases. One is you consider the phase 1 is foundation, where you set up the ingestion, plan the wall lake integration, design the low latency system with the real-time intelligence service within Microsoft Fabric. Phase 2 is pilot it. So release it for a subset of the fleets, 10 to 15K, 50K vehicles, validate the ingestion, deploy the dashboards, make sure everything is all data flow is happening continuously, reliably, at scale. And then the last phase is validate. So in that case, you test the peak loads, validate the alerts whether they are happening correctly, accurately or not, train the operations staff on these use, and also enable this automated decision making based on the alerts, etc. Okay, so next is reference architecture versus our demo script. So core capability that we are going to show in the demo is how do you do real-time ingestion? How do you do analytics of the streaming data? How do you set up alert with activator? How do you add business context using digital twin and entity and relationship? And how do you use the real-time dashboards, etc. And then when you apply it to the enterprise scale, you're going to extend that capability by including other data sources, one like integration with the traffic telemetry coming in from the outside sources, machine learning model built on top of this data, geospatial analytics using the geospatial data coming in from these fleets, and enterprise monitoring and governance. So that is pretty much it. Context layer is the most important layer. We talked about the context layer. Context layer is that the additional business information that you're getting through the entity relationship, the graph, knowledge graph of the enterprise, the common meaning of different entities and how they relate to each other, etc. So the data agent can connect the dots and be able to recommend actions and decisions accurately. So operational context can be implemented through the digital twin models. Structured metadata tables can come from the Wall Lake and integrated with the enterprise data sources. The core pattern is you get the signal, you add the context to it, you make decision, you act on it. Okay, with that, we are going to jump to the demo.
Okay, so far it was just lecture. Now I'm going to jump to the demo. This is completely, on Microsoft Fabric real-time intelligence. As I said, real-time intelligence is one of the service within Microsoft Fabric, and it's a unified data platform. Hopefully everybody is aware. If not, I would strongly recommend that you go through the documentation and read about this. There's numerous, Microsoft documentation that you can follow. Let me just start the demo now. So pay attention to this. I'm going to show you end to end all of the services that we discussed. Okay.
Okay, so now we are going to see how you can use Microsoft Fabric Real-Time Intelligence Service to build this use case for fleet operation and intelligence platform. Okay, so once you come to app.fabric.microsoft.com, you will see there are two personas, Fabric or Power BI. You're going to switch it to Fabric. You come to the welcome page. It asks you to create a workspace. Create a workspace for your own project or team where it will organize all your work artifacts and products. So for me, I already have a workspace. Within that, you're going to go to your corresponding folder. There could be multiple, folders there. Let me just show you how it goes. Yeah. So in this particular, workspace, I have this folder. Go inside that. You have the services. This is the list view. This is the lineage view. I can filter it on a certain word just to filter out all my services. It is connected to source control Git repository to the develop branch. So you have the CI/CD process already enabled. Event stream is how you're going to ingest it, route it, filter it, and do some light transformation. Then you're going to store it to the KQL Kusto query language database within the event house. This is for ingestion. This is for storage. Event house is for high volume, columnar compressed, engine, which gives you blazing fast performance for these type of time series data. You can also build dashboard on top of the data sets within the or tables within the KQL database. And with real-time intelligence, you can use Power BI to do direct query mode to also do complex visualizations. You can also have other data sets coming in, not only your telemetry coming from the vehicles, GPS, traffic information, but other vehicle depot, driver, what else, routes, etc., traffic condition, etc. Related information can come from other systems through batch process to lakehouse through data factory. And from there, you can actually build digital twin, which is a digital representation of your physical infrastructure. So you basically create a business data model on top of your lakehouse tables or event house and lakehouse table to create an entity relationship data model, which will be used then by the data agent. As you can see, there is this data agent. Data agent is a conversational analytics agent, which has the LLM bridge, and it uses the data sets that you're going to add with the instructions and the ontologies and the rules and policies to be able to give you the next best recommended steps, analyze your incidents, analyze your operational signals, and give you what needs to be done, corrective action, following the rules and policies and the relationships and entities defined by the ontology, which is part of Fabric IQ. And you can also set up alerts on top of your event stream. So as the stream signals are coming in, if any combination of signal goes beyond certain threshold based on the definition, it can alert Teams notification or email or downstream process. It can trigger a Power Automate workflow or any other data flow. Okay, you can also, what else? An ontology is here. Yes, yeah, I'll be able to show you the ontology in the list view. So the list view shows you all these services. Activator for reflex for triggering. Digital twin for creating entity relationship data model on top of your data stored in your lakehouse and event house. Event house for storing the data, or this is the lakehouse. Event house for storing the time series telemetry data. Again, time series data for event-driven operational analytics, not schedule-driven. Event stream is for ingesting. Data agent is for conversational analytics and getting, automating the recommended step actions analysis of the situation. Lakehouse is for storing other contextual information that you need. Ontology is for creating rules, policies, entities, relationship. It is a combination of similar functionality as digital twin builder and activator. Combined together is ontology, which is part of Fabric IQ. And I already talked about real-time dashboards. Let's jump in. So I have, in my case, let me just move this. Yeah. So I have a notebook. First of all, the event stream. Let's go to the event stream. So event stream is the service which is ingesting the events. And how I simulated these events for telemetry is through a custom endpoint. And that endpoint is actually, there are different protocols, Event Hub, AIM, QP, and Kafka. I've used Event Hub. So you can take this Event Hub name and then the connection string primary key. You can create a notebook which will uh, start generating streaming events. Okay, so for that I have a command cell which is installing Event Hub, and the another command cell which is creating some functions which is going to be delivering this telemetry with the construct that I've defined. And then the subsequent cell is how I'm going to start generating the string. So this is the notebook which is kind of generating continuous stream of telemetry of these fleets. And through this endpoint, I'm capturing it, okay, because I'm connecting the notebook to that particular endpoint with this, connectivity details. And then after I connect it, the live events is going to flow in here. So right now I am on 512, and you will notice, because it's already 12:46, you will notice that this is actually UTC time. And if I go back, you will see in the notebook, the stream event has started to generate. You can see it's running, and this is actually live flowing in. So this is actually live data coming in. And as you ingest it, you can do transformation, filtering, and then you can store it in the event house. You can also set up thresholds, set up activator alerts. So if you go to event house is where it's basically it's a optimized storage engine for this type of data set. So it has columnar compressed storage. So storage costs lower, performance much faster. Also, data gets stored on the order of the timestamp, ingestion time clustering, call it. So it gets automatically indexed. So you can have multiple databases within the event stream. And within each database, right now, I am using this KQL database. If you go to the database, its summary screen shows you the overview, the entity relationship diagram for the tables. You can make it medallion architecture based on bronze, silver, gold to process the data. First ingest it to bronze, then apply policy, remove filter, load it to silver, then do time-bound aggregation, load it to gold. For now, just for the simplicity's sake, I kept it, this table is getting the streaming event. So if you go here, this is how the streaming, it's continuously coming in as of now based on the notebook getting generated. This is a JSON payload, event ID, event timestamp, vehicle ID, route ID. If you keep going, key value pair, report ID, depot ID, driver ID, GPS location, latitude, longitude, speed in kilometer per hour, battery temperature in centigrade, brake temperature in centigrade, door open, true or false, occupancy percentage, delay in minutes, maintenance mode, true or false, etc. So that's the telemetry continuously coming in. Now you want to analyze that data and make sense of it. You do that using KQL query set. This is similar to SQL language. KQL stands for Kusto Query Language. If you know SQL, you can very quickly, very readable, very easy to understand and learn. Can learn that. Or if you want to use Copilot, you can give English prompt, it will generate the KQL query for you. Okay, so here you are going to analyze and make sense of the streaming event that's coming in from the fleets to see what incidents are truly needs attention and which ones are priority, etc. You can also visualize this. So as you write queries and you can run them. So suppose I run this one, and then you can actually pin that to a dashboard as one tile. So it's currently running and it's going to populate to a table or tabular format. You can also do visualization, but you can actually post it to a dashboard. So either existing dashboard or new dashboard. Okay, so that's it. You can also create Power BI report by connecting to these data sets or to SQL queries. And I already talked about Copilot. Next is the dashboard. So I have two dashboards already built. This is called real-time dashboard. This is to visualize the streaming data. So you can have multiple tiles. You can set up, refresh frequency as much as you need, whether it is automatic if you want to enable. You can see there are continuous 10-second, 30-second, etc. frequency. I'm going to cancel that one, and you can have multiple tiles. Each of them are nothing but it's a KQL query. So if you go to the edit mode, pencil icon, it shows you the query and then the output. And this is the visualization. Right now it is a tabular. You can have multiple other types of visualization, as you can see. So you can make sense of the data, kind of run chart, etc. with this real-time dashboard. You can also use Power BI for complex dashboarding. You can have, once you move it to the viewing mode, can also be able to use Copilot to talk to the data, add alerts to it based on the fluctuation on the tiles, on the different tiles. Okay. Next is activator. Let's look at the activator. So to pull activator, I'm going to go here and then I'll get the activator opened. So activator is for alerting, triggering. So it's a reflex layer. So whenever a combination of signals goes beyond certain conditions, you want to be notified to certain people. So here is that activator, the stream that is coming in. You have set up an alert, and this is the rule. It's populating it. It's coming in. So I'm opening it first time. So this is the rule. So this is the event stream. On top of it, there it is going to check for three conditions. Condition 1, 2, 3. One is checking for bake temperature greater than this, battery temperature greater than this, and delay in minutes greater than this. With that three combination, when it is made by the signals, it's going to send email to me with the subject and body and headline with the runtime dynamical components coming from the stream. So that's how you set up an activator as the stream is getting ingested. This is the live feed option. As the stream is so it's populating. So I'm opening it after a while. So that's why it took time. I could have kept it open. It would have been faster, but it's basically as it is ingesting, it's detecting and inspecting those stream of events and then applying the rules that you have defined, and then accordingly it's acting on it. Okay. So next is Lakehouse. So we need Lakehouse for getting other data sets, not only the signals that are coming from operational fleets, but any other operational databases, ERP systems, CRM systems, any other operational store, SQL Server, change data capture that's coming in. Think of vehicle specification, route details, depot details, etc. You are going to load them into Lakehouse through the data engineering workload, data warehousing workload, and think that is already done. The tables are available. Now you're going to use these lakehouse tables to build a ontology. So how you do that? You can also build ontology and digital twin. There some digital twin is normally used for manufacturing, but they both have similar functionality. Basically, ontology and digital twin are part of Fabric IQ, which gives you the ability to create a unified business data model, or business data model on top of your data stored in Fabric, whether it is Lakehouse or Eventhouse or in other places. So how do you do that? Is basically you define entities, you define relationships. Entities are your tables. Relationships are verbs, like how they are joined to each other. So tables are their nodes. Ages are connecting links, are basically the join conditions. So that's how you build an entity relationship data model on top of your data stored in Lakehouse. In this case, we are building it on top of the Lakehouse table, vehicle, depot, and route. So this is when you add that model entity on top of the table, it will ask you which table, what are the primary key, what are the property. You can also add this relationship, which is basically the join condition, how these two tables relate to each other, like we do normally in join conditions. You can also add rules to the table. Like if you go here, there's three dots. If you go to manage rules, there are three rules I've created. Why rules? Because you want this, like you want agent to act on top of the organizational policies and rules and not on its own. So these are the rules you're going to give to the agent. Ultimately, you're building this to create a unified semantic model, which will be used by data agents and human users, etc. So these rules are going to be complied by the agent in its recommended steps and actions that it will recommend. Okay, so that's your ontology. And next is digital twin. Digital twin is also similar functionality, except here it's for manufacturing. You also create the entity relationship diagram here, and that's being used as a semantic model. Think of Power BI semantic model. Here it's a Power BI doing it multiple separate dashboards. You're doing it in a single unified place in the data platform in Fabric and in directly in the Fabric itself, in Microsoft Unified Data Platform Fabric itself, so that you don't have to get it siloed or disparate or not matching with each other, etc. So the last thing is the data agent. Data agent is that, so we ingested, we processed, we stored, we make sense of the data, we activated alerts, we added a semantic data model, business context. Now we are going to build the decision layer is basically the data agent, the conversational analytics, and to give us to automate the whole process of what's the action to take through the data agent. So for data agent, what you do is basically you add data sets to it. There are 5 data sets allowed at this point. It's generally available. You can add as much as 5 data sets. It could be KQL databases. It could be event house databases, which is KQL, or lake houses, or ontology. I've added a KQL database that I have the fleet data and the ontology that I created. Okay, so those are added. As you add, you also have to set up, give instruction. So like the agent has to have instructions. So you're building a agent, which is kind of a automated. It will work with the LLM branch. It'll have text, natural language prompt you will give. It's going to convert it to KQL query, and it's going to run the query. Then it's going to analyze the response. It's going to collect the dots, assemble the answer, create a narrative natural language response, and give you the results, give you also the lineage as how it came up with that answer, so you can verify. So you have to tell agent, just like a regular human agent, you have to tell an agent what table, what is his purpose. So we are saying you are a fleet operation intelligence agent for this transit command center. You have 2 kinds of data sources. These are the tables. You have this is how you define a incident rule, detection rule. You're defining the rules here. You're not telling agent to directly assume the rules or decide on its own. You're defining everything. Ontology policy rules. You're also mentioning any additional information, and you're also going to put a guardrail like do not respond to anything other than, do not make things up, etc. Other than the data sets that is there, the answer from the data, don't make things up. So data set instruction also, you can say what is the description of the data sets, what other description mean, what table, what are the tables, what data do they contain, and then data source instruction is if certain question is asked for, how do the agent answer, etc. So you're going to natural language explain it. And you can also give some example query like ground truth. This is the natural language question. This is the KQL query. This is the natural language question. This is the KQL query. So it's like a baseline benchmark against which the agent will be able to answer based on this pattern. It's going to learn from this. Okay. So with all these, you're going to author and then you're going to publish. I already published it. If I go to the draft mode, I'll show you when you go to publish, it tells you that you can also publish to the agent store in the Microsoft 365 Copilot. So why would you publish it? Is because you want to give it out for people to use it, right? So if I go to the published mode, and then now you can start talking to the data as an agent, as a virtual agent, or you can automate this process and the agent generated output can feed into an action layer. Okay, so what are the historical trends in the data? It gave you these historical trends. Okay, you can see how it came up with the answer, the plan, and then the corresponding KQL query, and then the output. And then finally, it gave you the answer in natural language based on the query output, right? So it didn't give you the tabular structure, it narrated the answer. Similarly, I'm asking, it's conversational, or you can add follow-up questions, recent data for any outlier. So based on that, it is giving you answers. So this is how it goes. So again, you can see, you can work with this, play with this, and you'll see it gives really, really, dig deeper, and it writes very, very complex SQL queries. Now, again, this is AI generated. It's text to SQL ALLM running. So you do check the queries, make sure they are giving you a correct answer. But most of the time, it's doing pretty good job. If something it is not giving accurate, you can change the instructions. Okay, so this is your decision layer, and then the act layer is through the trigger, right, or through human in the loop workflow, where a supervisor, the activator sends an alert to a supervisor. Supervisor will review, and then supervisor will approve or deny based on whether a dispatch vehicle will be sent or to replace one fleet which is in, which is in failure, mechanical failure, or in high priority route which needs attention, etc. Okay, so this is kind of a scenario which shows you end to end, all the way from ingesting the signal to processing, making sense of it, then act on it, or making decision as what needs to be done, and finally acting on it. So hopefully this makes sense to you, and that's all I wanted to share.
All right. All right, everyone. Now it's time for question. So thank you all for joining. I see 18 of you. Hopefully you learned a lot. Now let me know if any question. We have few minutes. We have about 10 minutes to take questions. And feel free to unmute yourself. Can they unmute themselves, or you will have
No,
to write?
I informed like they will raise the hand digitally so that we will unmute it.
Awesome. Okay. Go ahead. Don't feel shy. If any section you didn't understand, please ask me.
Yeah, there is one question actually, so I will read out for you. So can
Mhm.
we have a GitHub link for this demo? Is
Oh,
asked by Suchit.
yeah. So I actually recorded the demo, and right now it is in my work um, workspace. So I'm not sure, but you probably will get this particular meeting is getting recorded. So if you replay this, you will be able to see. And I would strongly recommend that you go, you know, take a free subscription for Microsoft Fabric and then try this out. They're very simple. They're low code, no code solution. If you notice, I haven't written much code. Those KQL also you can write through Copilot. So, and it's all of like UI driven. Does that answer your question, Ashiri? Um, yeah, your hand is still raised. Okay, thank you, Suchit. I think Ashiri now has a question.
Yeah, you can unmute us.
Yeah, thank you. So when you are getting so much of data to Fabric, what about the cost storing them?
Yeah. So, like any cloud data platform, if you are using, obviously the compute will cost, right? So cost is again, you can you can look into the cost control, you can look into the system monitoring view and see how it is consuming cost. But as the streaming events are coming in, it is getting ingested and getting loaded to that event house. So those processing like event house engine will cost Fabric unit capacity units. So those are there. You can't work in cloud without those compute costs. They are not like, they're also data center, right? And Microsoft is maintaining those. uh, Fabric is a software as a service platform. It is a low code no code solution. You literally get everything provisioned. You don't have to provision anything. So cost control is, again, there are numerous articles, blog posts, and videos also you will find on how can you control the cost of Fabric capacity unit. And this is a real time intelligence. Like I would suggest decide the frequency of your data processing based on how fast the data is changing. If it is not changing fast enough, don't make it. Like choose that refresh frequency appropriately. Like if you are ingesting it, it's continuously coming in the streams, right? So that event house is very optimized for high volume, high velocity data sets, high granularity data sets. So that's not a problem. You will not consume much cost on those. The places where you can consume more cost is probably Copilot use. Be cautious about that. Use Copilot like in the situations where you truly need support, not to write simple KQL queries, etc. Also, if you build these dashboards, the real-time dashboards, don't refresh their frequency. Don't set them as a refresh continuously or refresh every few seconds, because that will again cost, the refresh will cost compute. So be cognizant about compute usage and then monitor, and that should give you a good state. And that's how it is for any lake house data platform, whether it is Fabric or Databricks or Snowflake or any other platform. Hopefully that answers your question. Go ahead, Melcos, sorry. Thank you, Ashiri. Melkos, you're next. Are you
You
able
have a
to
chance to unmute yourself and ask your question to Rakshit. Yeah.
Okay, I'm here. Yeah, this is Melkos here. It's a wonderful session. Thank you so much. And see, now the streaming data is being stored in and the event house and the database, right?
yeah,
Suppose I want to store the event stream data in my lake house. I mean, in my data in a delta table or warehouse. Is it possible to stream from Fabric?
yes.
Now we
So
are getting the streaming data from outside, right? Now I want to stream my Fabric data to outside. Is it
yeah,
possible?
yeah,
And
yeah,
if
that
so,
is
how?
also possible. Yes, yes, it is possible. So, like I showed you a simulated notebook which was producing the time series data. Similarly, say suppose anything connected to the IoT Internet of Things connected to the internet will be emitting telemetry, like your thermostat, your Fitbit or Apple Watch. If you can mute yourself, that'll be great because there's a lot of background noise. Let me mute you so that I can speak. Okay, okay. So yeah, the sound is gone. So basically, your question is, can I have Fabric event also captured as a telemetry? Yes. So like if you create any workspace, we create any, any other items, and those creation are also events. Think of it like Microsoft itself uses this event stream and event house. They are previous name was Azure Data Explorer. So in the Azure platform, there is a service called Azure Data Explorer. That was the previous incarnation of this event house and event stream. So what Microsoft did is they took the Azure Data Explorer, which is a very like a decade old service, and they use it for all of their log mining, huge petabyte scale data processing for all of the infrastructure for Microsoft Azure cloud. So it's a seasoned product. They took it and put it inside Fabric and called it event house and event stream, etc. So yes, you can also generate Fabric related Fabric workspace or any other item that you create. Those will also be able to trigger time series data that you can capture through the event stream and process and see who is doing what. Like if you want to audit the platform, like what are the people who are creating, let's say workspace items, maybe data flow, maybe in a storage account, you would like to know those, and those telemetry will tell you that story. Okay, hopefully that answered your question. I had to mute you because your sound background was very noisy. Yeah,
Right. Yeah. Thank you so much. Yeah, you answered me. Thank you.
thank you. Yeah, please go ahead and connect with me. I think Rajendra is posting the LinkedIn, my LinkedIn, and you can read my profile and bio. And I write a lot of articles also. I share a lot of industry, what's happening in the industry, whether it is Databricks platform or Fabric area or real-time intelligence or any other. That would be useful for you to follow me so that you can also get those feeds. I see one more hand raised. Prakash, go ahead.
Yeah, hi, this is Prakash. So we have the 256 capacity on the production, and when the semantic models are connected to the direct lake, and users are creating the reports on top of that as well. Do we have any area or like, so how can we see that? Like, for example, like I have a dashboard with 5 tabs, and is there a way that which particular visual I can get that? So till now, like what I have done was like I get that DAX into the KQL, and then I created the lakehouse, and on top of that, I created a report, but I cannot pinpoint to the exact visual like what they are doing.
So you're saying, let me understand. So you said you created a dashboard on a lake house table, and that table you're
Yeah,
getting
so
it from the
basically,
event house. Mhm.
let me clarify that. Like, so we have a Databricks environment. From the Databricks environment, we are using the mirrored catalog to the Fabric, and
Okay.
we are getting all the tables into the Fabric, and then we have created a lakehouse, and on top of the lakehouse, like SQL endpoint analytics, we
Mm-hmm.
created the semantic model. Okay,
Okay. Mhm.
From the that's a, that and on top of that, like users and also the direct DT team, digital team,
Mhm.
like creating the reports. So
Okay.
basically, like when we created the reports as a DT team,
Mhm.
we know we follow the standards, like where we have to use these particular measures, and then
Mhm.
performance tuning process, like we are creating.
Mhm.
But
Mhm.
when sometimes like the users are creating, they're not following that approach, and then
Mhm.
that is causing the spike on the even 256 capacity as well.
Yeah, 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 yeah. So you have to because this is on cloud, you cannot let the users to like go rogue and create all kinds of bad queries and the dashboards. It's going to cost you a lot of money. You have to probably limit who can have the ability to create semantic model and create
No,
dashboard.
semantic model is restricted to DT team only. But we
Okay,
have
good.
given the self-service reporting on top of the semantic model, which
Okay.
is causing the spike on the capacity, and it is causing, 8 o'clock Eastern time to 12 o'clock Eastern time. Users
Mhm.
are very much interacting to the reports, and then that is causing the spike. Even
Yeah,
though like
and
such protection is also not helping much on that, because like
okay.
it creating entire capacity down at the time, because at least like an hour, like we have to
Yeah.
wait for that.
Yeah, I can completely understand. So they are literally trying breaking the whole system because
Right.
of overuse and etc. So I would say now it is like it's about human control. We do have to put some control in place, like your team have to discuss with that users who are trying to do the self-service analytics to say it doesn't make sense that everybody goes and builds their own reports, particularly when it is costing these capacity units. I think it would be better that as the requirement is taken from them, what are the possible reports that they need, and then
Right.
build those and then give it to them as a consumer as opposed to they building it from scratch. If they want to do something, they can again uh, you know uh, they can do it in Power BI desktop if they want to play around with it by exporting the data sets, etc. But I would strongly recommend that don't let them do self-service analytics on the Fabric, on the Lakehouse table using this capacity unit because it'll be a like moving target. You will never be able to control it. It's going to be totally uncontrolled environment and your cost will be very high.
Yeah, yeah. So thank you for that. As a follow-up question, like, so is there any way that like we can get the bottom of the visual, like where this particular is spiking up? Like for example, I'm having the 5 tabs in the dashboard, and then each tab like is having the 5 to 6 visuals. So a particular is I'm pinpointing to the DAX query, like where it is causing, but the thing is like I want to visual to look into that one. I didn't find that, like is there any can you give an idea on that, like how
Yeah.
to achieve that solution?
Yeah. So I would say in this case, what you have to, so you are basically trying to understand sometimes some of the dashboards are slow and you don't know which tile is causing that issue because
Correct.
there are multiple different tiles. They have
Right.
different queries. And I would say you will see when these dashboards are built with the on top of the semantic model, and then the queries are defined, they're all getting logged into the system tables, right, in
Right.
Fabric.
Right.
So
Yeah.
I would say Fabric log, you probably have to look into the documentation. I can't tell exactly off the top of my head, but it has to be that somewhere it is getting logged in system tables. And with
Mm.
Microsoft's help, you can either have them build a dashboard on top of it and give you the dashboard so you understand what queries are running. There has to be that these queries are logged, right?
Right. Right.
That log file, if you get it as extracted out and then you can ingest it into an event stream to an event house and then explore it with KQL. That would
Yeah.
be another use case.
Okay. Yeah. I'll try to explore that option. Thank you.
Thank you, Prakash. I think we ran out of time. It was very nice talking to all of you.
Yeah, yeah.
Hopefully you
Thank
learned
you
a
so
lot.
much, Rakshit. Yes,
Thank
thank
you,
you so much,
everyone.
Rakshit, for your time and sharing your knowledge on RTA topic. So we'll meet you soon. And next speaker is also ready. And Ravi Kiran,
Right. Yeah, Rajendra,
you
if
there?
you don't mind,
Yes.
just I'm probably going to log off because I have to catch the flight. I just wanted
Sure,
to
sure. Please
see
take
how
care.
many
Yeah, yeah.
attendees have attended and etc. If you give me
Okay.
those statistics, and